Hi friends, this is Sri Ramulu. So today's topic is very important for the exam point of view. So what is that? This is the application of Biot-Savart law. So by using Biot-Savart law, we can calculate magnetic field due to a straight conductor carrying current. Okay, so straight conductor. Straight means how much straight? It is a long straight means up to negative infinity to positive infinity. So that much of long straight conductor it is. So by using this conductor, how can we calculate the magnetic field? This is our side heading. Magnetic field due to long straight conductor carrying current. Now see. Consider an infinitely long conductor placed in vacuum and carrying a current I ampere as shown in figure. So here figure is important. So must keep in brain or mind. It is a infinite long conductor. This side is a negative infinity. This side is a positive infinity. That much of long. Then this is a middle point or foot or base. The aim is to derive an expression for magnetic induction B due to conductor at a point P on x-axis using Biot-Savart law. So see, by using Biot-Savart law only, what we have to calculate? We have to calculate B at a distance from the conductor. Okay. Next, let the distance of P from the conductor be R, capital R. So this is, it is a perpendicular distance, and O is what? O is the foot of the perpendicular from P to conductor. Okay, so from P to the foot, this is the foot it is. Consider a small element AB of length dl of conductor at a distance L from O. So what we have to do? We have to consider the small element on the conductor at what distance? At L distance. From where? From O. See here in the diagram. Check it. So from O, how much, at what distance? At what distance it is? At L distance. How much length we consider? Small length. So that is why we are saying that is element. How much its length is? dl, small. Okay. Let r be the small r here. Capital R already over. So now the small r. Small r is the be the distance of element from point P. Okay, so this distance from point P. Suppose theta be the angle in clockwise direction with which the direction of the current makes with the line joining the element to the point. So here angle, this r is a distance from considered element, and what is the angle? It is a clockwise he is seeing. Now see here, clockwise direction it is. Where to where we consider the element from there to distance at which P is situated from the considered element. So it is angle, clockwise angle, and it is a distance r. Okay. The magnitude of field dB due to element AB at P is given by. So at this point, how much field present? That field we are going to calculate. Okay, so let at that point the field is dB. Why it is small? Small length we consider, so that is the field is also small. If you integrate it, you can get total field at that point with the help of the long conductor. Next, the magnitude of the field dB due to element AB at a point P is given by. So it is a Biot-Savart law. dB is equals to mu naught by 4 phi into I dl sin theta by r square, right? Once again, dB is equals to mu naught by 4 pi into IDL sin theta by r square. Now integrate it to get whole field, total field by the conductor. So when we integrate, so if integration difference cancel, we get B only. Okay. And this side. So where to where we have to integrate? Length of the conductor is from negative infinity to positive infinity. So limits are negative to positive infinities. Now here what we have to do, we have to calculate what is the sin theta value, r value and dl value. If you substitute here, and after substituting, if you derive it, if you solve it, then we can get final answer, that is the B. So for this let me calculate it, derivation. Okay, same thing is written once again. Let it is equation number 1. So here from figure, a right angle triangle POA, right angle triangle POA, where it is POA, POA. So see, this is right angle triangle. Okay, so how it is? Like this. So it is what? Capital R. Up to here it is L. Check it. Okay, and this is small r, isn't it? Okay, capital small L, small r, capital R. Okay, so keep it in mind. And one thing what we have to do here, so here to here angle is theta, then what is the total angle? We know that is 180. If you have to get only this angle, then 180 minus theta gives that angle. So what is the angle? This, it is what? 180 minus theta. Okay, so from total angle this value is subtracted, then we get this value as 180 minus theta, means pi minus theta. Okay, so which triangle? POA triangle we are considering. Okay, well, let me draw the POA. So it is point P, foot A, this length is L, it is capital R, it is small r. From diagram just now, it is angle alpha is given. Okay, so you can see the alpha value also. And see, according to Pythagoras, what we can write, hypotenuse square is equals to side square plus side square. Hypotenuse square is equals to side square plus side square. Hypotenuse square is equals to side square plus side square. Is it? From this r is equals to, so this is we can write. And next, just now I told you, this side angle is how much? Pi minus theta. Just now I explained you. So apply the sin theta. Sin of pi minus theta is what? Sin theta only. Sin of pi minus theta is sin theta only. So sin theta is what? Here angle is pi minus theta or sin theta. So opposite by hypotenuse. Opposite capital R by hypotenuse small r. Okay. So sin theta we got, small r value we got, sin theta r value. So sin theta is what? Capital R by small r. Small r is what? R L square plus capital R square power 1 by 2. Okay. Now substituting the value of r and sin theta in the equation 1. So what is equation 1? Here once again written equation 1. And see here in the equation 1, sin theta is what? Capital R by small r. And one thing also we can write, capital R by small r. Small r formula is given here. What is that? L square plus capital R square power 1 by 2. So here see, capital R by, this is a small r term. By here r square term is what? R square is L square capital R square. Okay, so both the terms are written, don't get confusion here. Right, see here, sin theta formula, sin theta is capital R by small r. Small r formula is this one, L square plus R square power 1 by 2. And next, for what formula? By R square is there. R square formula is L square plus capital R square. So these two are multiplied in the denominator, isn't it? So see here clearly. from figure, right angle POA. Same thing from right angle POA. So see here, let me draw here. It is angle alpha POA. It is L, capital R, small r. Okay. So apply the tan theta. Tan theta is what? Opposite by, so opposite by adjacent. Opposite by adjacent. Opposite L, adjacent is R. It is hypotenuse. So we don't need in tan theta, only opposite by adjacent. L by R. From this L is equals to. And differentiate this equation. L becomes dl, R constant. Tan theta formula derivation is secant square alpha d alpha. Tan alpha formula is secant square of d alpha. Okay. See here in the diagram there is a dl. We didn't find a dl value. Now we can substitute here. Before substituting here, limits also we have to change. Okay. In tan theta, limits infinity where we get at 90 degree. Positive infinity at positive 90, negative infinity at negative 90. Right? So all those things are also written here. See, limits under this situation becomes minus pi by 2 plus pi by 2. So it is belongs to minus infinity, it is belongs to plus infinity. And substitute dl value in the above equation. In this equation, here dl value substitute. So what we got dl value? See here dl value substituted. Okay. And now see r into r square. So it didn't write. And before that, L value is what? Just above it, L value see here. Check it. L value is what? L is equals to R tan alpha. So, but formula, actually see the formula here. See the equation 2, L value is there. In the L value, substitute this value. And R square is right as it is. In the place of L value substituted. Okay. So, L square is there. So, that is by R square tan square alpha it is. Now, take outside R square common. R square is already in 3 by 2 only. So when you bring the r square from 3 by 2, 2 can get cancelled. R power 3 we get. So see here r power 3 written here. And this r into this r square. So upside r square. Secant square alpha, secant square alpha. Okay. In the bracket in the denominator you see tan square plus 1. Tan square plus 1 is secant square. So right here secant square. So square this 1 by 2 cancel. Only 3 present. 3 means secant cube. Secant cube. Secant cube but upside secant square gets 2 things and only secant alpha will be there. 1 by secant alpha is cos alpha. 1 by secant alpha is cos alpha. And see the limits are written. Minus pi by 2 to plus pi by 2. Minus pi by 2 to plus pi by 2. 1 by secant alpha is cos alpha. Integration of cos alpha. Integration of cos alpha is sin alpha. Now substitute the first what? Pi by 2 in the place of alpha. After doing minus pi by 2 we have to substitute. But sin of minus pi by 2 answer is minus sin pi by 2. That means sin of minus theta is minus sin theta. Okay. So here positive term we can substitute. After doing minus, sin of minus pi by 2 is minus sin theta is written. Now minus minus becomes plus and sin 90 is 1. This 90 is 1. 1 plus 1 2. 2 2 ja 4. So finally what we got? We got as PB is equals to mu naught I by 2 pi r. So this is a expression for the magnetic field induction near a long straight conductor. Long straight conductor. It is a long straight conductor. And what it explains, B value mu naught I by 2 pi r. 2 pi r is the circumference of circle. So that means magnetic field how does form, around this infinite long wire. So in the form of circles only like this. So diagram also given here. So circle, how can we understand? By 2 pi r formula we can understand So circle will form around current carrying conductor. Concentric circles only. Concentric means the circles whose center is same, that is called concentric circle. And friends, it is very very important. So if you want to listen it twice and write in the examination without watching. Okay, thank you friends.